Hey guys, in this video I'm going to teach you how to model a set of drawers like this in SketchUp so that you can plan your work out before you actually make it. So let's get started. Anybody who's used SketchUp before knows what a powerful bit of software this is. It's beautifully simple at the lower end, you know, for new users. It's really intuitive. I haven't used it for months, and every time I go back to it I always remember all the commands, so it's really good. But at the higher end it's very powerful too. It's got a huge global user base and open source, you know, assistants, plugins and various things like that, so you can do all sorts of 3D modeling and surfaces and stuff. I like to use it for even small projects like cabinets and kitchens and things because it's adjustable and helps me plan out my cutting list. So I would strongly advise that you have a go at this. It's free online, or you can buy the paid for version. It's got more functionality, but you can still do some basic things with the online version. Okay, so first of all, you're going to open up yourself up a new file and save it, which I've already done. Then we come with the obligatory human. We'll get rid of her or him, whatever they are. Now, I'm going to start off with building my carcass. So I'm going to start off with the base. So I'm going to select the rectangle tool and put it on here. Draw it out. Now, all I have to do is plug in the dimensions that I actually want. So I want this thing to be overall 570 wide and 450 deep, but I've got a 12mm backing board going on the back, so I have to deduct 12mm off of that, so it's going to be 438. So we're going to say, because it's in meters, we're going to say 0.57 comma 0.438. Okay, so that's our base. Now what we're going to do is select the surface, extrude it, just click on there and you can drag it up and down, and then you're going to type in the actual distance you want. So this is a 18mm piece of MDF, so it's going to be 0.018 thick. Now comes the clever part, and I strongly advise you build all your models like this from the get-go. It just makes life so much easier, is to build things into components and groups, and that way you can just copy and paste things from different projects within the project. So I'm going to select that entire thing, and I'm going to right click, make component. So I'm going to call it carcass base. Now what I want to do is make a copy of that for the lid, for the top. So we're going to copy, Control C, paste, Control V. Okay, but now I want to make that unique. Make unique. That means now it's not only is it not a copy of this, but it's also not a component. So now we can create a new component, but to make a component we have to explode it first, then we can make a component, and we're going to make that carcass top. Okay, that's good. Right, now we want to make our side panels. So let's just get ourselves in the right view. Now, this is a good little bar. If you right click up here, you've got all the menus up here, and I use the views bar, which is really handy. Just make sure you click the right one. Okay, so that's good. It just makes life easier, otherwise the computer may end up grabbing or putting you in the wrong plane. So I just want to draw my rectangle vertical now. And what I'm going to do is just hover over the corner point there and very gently try and keep it in a straight line, drag along, and you probably can't see it, but there's a very faint dotted line there, and what that means is it's pinning itself to that corner so that you stay in the right plane. Otherwise it might end up drawing it somewhere miles off in the distance. Okay, so I'm just going to start there and draw it out. Now this one needs to be 650 high and 450 wide. So again, we're losing the 12mm on the back, so it's going to be 438, and the height I've got to deduct the two 18mm pieces of MDF, so I'm going to deduct 36mm off of that. So we've got 614 by 438. $614. Okay, that's good. Select that. Extrude 0.018. You can double click it to select it, or highlight it with the select tool. And then we're going to make component. We're going to call that carcass side. Now, I'm not too bothered about making a separate one for the right hand or left. I'm just going to just copy another one in there. Good. Now we can assemble it. So the way to do this is you're going to grab one of these pieces. I'm going to click the corner. Let's move it out of the way for a sec. I think we're going to rotate it first. That's probably the easiest thing. So click the rotate tool actually. Now you need to, as you hover your mouse around, you see it changes planes all the time. So we want the blue one because we want it in the flat plane. So I'm going to click on the corner there, draw a line out parallel to the unit, and then you're going to swing it round to 90 degrees and it will snap on the 90 degrees. So you see where it goes green, that means it snapped on the 90. Okay, now this makes it a lot easier to place onto the other unit. So we're going to scroll around, get our move tool, grab the corner, zoom in and pin it to this corner. Okay, and then we're going to do this one. I find if you just hover over and then just pull it down slightly, you get the blue one. Doesn't actually matter, it's not on the unit. So there we go, snap to the 90. There's several ways of doing this. Just going to rotate that around so we can see more easily. Then we're going to get the grab tool, grab the corner. There you go. And then we're going to grab the top, the lid. And we're going to pop that on top there. Okay, so that's our box. We need the back for it now, the 12mm back. Now you could just draw yourself a separate 12mm back, but I'm going to show you another way to do it. So we're just going to come to the back here. We're going to draw a rectangle on here. Make sure you click the right one, you may have to zoom in. Okay, there we go. So now we want to zoom that, extrude that out, excuse me. 0.012, 12mm. But you must create a component now, because otherwise this is glued essentially to the main carcass, and then it will end up pulling it in different directions, so you don't want to do that. So just click it several times, right click, make component, carcass back. Okay, so now if I want to, I can move it. If I hadn't done that, created a separate component, it would be dragging parts of this thing off in all sorts of directions. So you don't want to do that, so let's just escape that and leave that. So that's our carcass now. Most important thing, guys, is save your work. It's so frustrating, isn't it, when you put all that effort in and you lose it because you didn't save it. Okay, I thought now would be a good time to actually show you how to change the precision of the dimensions, because it's actually becoming a bit of a pain now for me. So we had it set like this. If we take it to one extra decimal place, we'll now get all the millimeters. So that's under Window, Model Info. Okay, so now, before we decide on what draw runners to get, we need to measure the depth of the unit. So we're actually getting now 420. So 420 millimeters. So we need to find something that's that or less. Okay, so let's go online now and see what's available. Now, before we decide on which draw runners to get, we have to make sure we get the right length. Now, they don't come in very specific derivations. They'll usually be 100mm lengths, or maybe 50mm half lengths of that. So it might be 350, 400, 450, something like that. And because we've got a length of 420, we're going to be looking at a 400mm length, as long as you can get in that space. Now, these ones are the creme de la creme, really, of the draw runner world. They are soft close and ball bearing. You don't have to have soft close, or self-closing as well as another feature. I do tend to find with these, if you're cutting a lot of MDF dust, you must keep it clear of these, otherwise it really affects the ball bearings. So you've got to keep them super clean. So they are a little bit finicky, but definitely the best quality. Okay, now let's have a look at, these are undermounted ones, so you don't have to have them on the side of the drawer. They could be mounted on the base. Then we have some very, very basic ones. You can get them even cheaper than this. And they don't have soft closes, but they are metal ball runners. Ball bearing runners. They run again on the sides of the drawers. You have some like this that are, they could be plastic or wood, and you cut a channel out of the side of the drawer box, and then they just slide onto that. Or they could sit on top of them, I suppose. That's another option, is just to have some wooden strips and then just literally sit the drawer on top, and they have no connection to the unit whatsoever. But I'm going to go for these ones. Now these you would typically find on the bottom of a kitchen drawer, and they have like a wheel at the back, and they slide into, they have a part that joins to the drawer, and then they slide into the channel, and super cheap. I've normally use the ball bearing ones, but I want to have a go at these ones this time, and they will sit on the bottom of the drawer. So if we scroll down and we look in the question and answers for the thickness of these, so how much clearance do you need between drawer and the side of the cabinet? 12.7 millimeters. I prefer to do the drawer fronts before I do the drawer boxes. I can plan them out on the face, and then I can attach the drawer boxes exactly where I want them on the back. Now I want to make sure that the top of my top drawer front does not clash with my desk, because my desk has got a little lip over it. So I need to drop down that 10 mil from the top of the carcass. And the way you can do that is with a tape measure, which not only measures point to point like that, it can also draw guidelines, which are really handy. So just drop it down, and make sure you see that blue line and it's on the surface of the carcass, not, because if you pull it over here, it can be somewhere within the carcass, which would be incorrect for what we need. So we've got it on there. I'm going to type in 0.01, and that will do my first guideline, and then one at the bottom, 0.01. Now there is a function in here that allows you to divide up equally between those 2 points, say 3 drawer fronts, but then I found it difficult to manage to achieve a 5 millimeter gap between the drawer fronts. I can't explain it in too much detail, but it's probably just easier for you, especially on the first time, just to attempt it this way. So all we're going to do is measure the distance between 2 guidelines, which is 630. Okay, now we need to deduct the 5 mil and 5 mil gap between the 3 drawer fronts. So that's 10 mil off of that. So that's now 620, but I can't divide 620 in my head, so well, it'll be about 207 or something. So divide that by 3. Yeah, 207 millimeters. Okay, let's drop a guideline down, making sure it's again on the surface, 0.207. Okay, now I'm going to create my 5 mil gap between this drawer front and the next one. Always have to make sure you're grabbing the right thing. Okay, 0.005. Okay, and then let's drop that down another 0.207. Move down. 0.005. Okay, so now the critical thing is whether or not this is actually 207 or close to. So it's 206. That's because we lost a little bit. It wasn't quite 207, but I can live with that, 1 millimeter difference. Okay, and now what I want to do is, I think what looks quite nice, the 5 millimeter gap is good. That's small enough that it doesn't look, you know, it looks nice and clean, but also it gives you a big enough gap that the drawer fronts are not likely to rub on each other if they slightly out of line. And also some of that we've taken up with paint anyway. And on the sides, I think 3 millimeters is a nice offset. So we've got to somehow grab the side and then put in 0.003. and then this side 0.003. Nope, didn't quite do it. 0.003. Has it done it? It's not. This is the thing, you've got to make sure that it's actually grabbing the right part. So I'm going to turn this around this way. It's gone inside the unit. Okay, that's on the surface, 0.003. Okay, there we go. That's better. All right, let's look at the front of it. Yeah, okay. So now I'm going to be able to draw my draw front. Make sure it's grabbed the right part. Move it over. Go back to the rectangle tool. So now we've created our draw front. Click on it, rotate, so we can see what we're doing. Extrude, it's going to be an 18mm bit of ply again, 0.018. Okay, and then we want to create that as a draw front, as a component. So this is going to be draw front. And then it's probably just easier to go now down to your components and grab the draw front. Not Stacy. Right, draw front. Okay, I need to see where it's grabbing it. So I just put it in place and then we're going to position it up. So it's still selected. Let's grab the corner and put the corner right there. Okay, another one. Grab the corner, zoom in, make sure it's on the right point. And there we go. Those are our draw fronts. So let's group those together. Which means we can move them all out at once. No, just keep it on that line, just makes it easier when you put it back. Now I want to hide the guidelines, so just go to View, scroll down and you see Guides. So I've hidden that now. So they're still there, but they're just hidden. Let's also make a group for this carcass. Make a group. Okay, so now we can start building the draw boxes. Before we go any further, I have actually made a slight mistake, but it will be a learning progress. Before we go any further, I have made a slight mistake, but it will be a learning process for you guys. So you know how I said that I wanted to draw my draw fronts on the front there? Well, that's because they're going to stop on the face of the unit. And I didn't allow for that 18mm in the depth of my overall unit. So now it's 18mm too big. But that's fine. You're going to learn now how to reduce the size of a component if you've made it too big. And just one point about making the draw fronts finish on the face of this unit. It gives it a nice positive stop. You can't really go wrong with it. If you start trying to do inset draw fronts, it's a lot more work because you have to make sure it all lines up perfectly. I certainly would suggest for your first project you keep it simple like this. And to be honest, I want to do this project as quickly as I can, so I don't want to get involved in that. And I'm happy with the look of the draw fronts finishing on the face. So how do we do this? Right, let's zoom in, move it over. Now the only downside to having all individual components, which helps you with producing a cutting list later rather than making one big box, the downside is that you then have to go through each one and make it smaller, but it's not an awful lot of work. So just click several times until you isolated the individual part. Now we're going to extrude it in reverse. And even though down the bottom here it says distance, it said minus point whatever, you're actually going to type in a positive one, so 0.018. I know it doesn't make any sense because you want to go in that direction anyway, but it does work. Okay, so in hindsight now, maybe I shouldn't have made the top and bottom different than I could have. affected both of them with that. So that's what I'll suggest to you, make them the same. Haven't quite got it yet, there we go. 0.018, so that's the thickness of the drawer front we're removing. But the sides should move back together. There we go, because they're the same item. Now what you can do, rather than type in, you can snap to the face of the unit. There we go. So let's just double check that. So this plus 18mm should make 450, which is what it does. Perfect. Okay, let's save that. Right, now we come to the complicated part. Drawers are actually pretty complicated for what they are when you're designing them from scratch. They look simple, you know, it's just a couple of drawer runners on the side, but to make them all line up, you've got to do a lot of planning to make sure it all works, otherwise you'll get binding drawers and it just won't work. So let's start off with this bottom one. So what I'm going to do is I'm going to work out what the width of my drawer is going to be overall. So let's go back to the unit. Just double check our dimension. .534, as I said. Now, my drawer runners, I will show you now, are 12.7mm. Well, we saw that in the ad anyway. So 12.7mm. So what you want to do is allow 1mm wiggle room either side, so that'll make it 13.7. Round it up to 14, double that, 28mm. So we've got to take 28mm off of the width of that opening, so 534. So 534 minus 28 is 506. Okay, but we can do it in from the edge of this unit. So this unit is 15mm overlapping on the edge of the unit. My maths is correct. So we want to come in 15mm plus the 14mm, so 29mm, and that will give us the outermost face of the drawer box. So 0.029. So that's taken into account the amount of overlay on the side of the unit and the thickness of the drawer runner with a little wiggle room. So then we do the same on the other side. 0.029. Now, from the bottom, I want the drawer runners to start 10mm. I'm trying to get it as low as possible, but I give myself a bit of wiggle room. I'm going to start them 10mm from the bottom of the carcass. So if we go back to the carcass, I want it starting the bottom of the drawer runner and the drawer 10mm from there, from the base. But also we've got to work out off of where the drawer front sits, which is in fact, we said we're going to be 10mm, so it was going to be 10mm off of the floor, so it's going to be 8mm. 8mm to that lip there. So 8mm plus the 10 is 18. Okay. So let's do a guideline of 18. 0.018. So that's going to be the base of our drawer. Now, from the top, I really want to maximise the depth of these drawers. That's one of the big reasons why I'm building the drawers, because you can never seem to get deep drawers these days. They're always really shallow and stuff falls out of them. So I'm going to go for, I know my drawer runner is going to also sit, let's just mark the other 18mm on. And we know where the base of our next drawer is coming. That's obviously the wrong part of the drawer. Just have to rotate it a little bit. And it's clicked on the wrong thing again. You've got to be so careful with this. It pays to zoom right in. There we go. So let's make that 0.018. So it's identical to the one below. And now I know that my draw run is going to start way up here, so I've got plenty of room, but I'm not going to take the draw all the way to the top, just for aesthetics. I'm going to drop it down, and I'm going to make it 15 mil down. Okay. So that is the externals of my draw. Now, if you look at most drawers, they usually have the side panels longer. So the side panels that extend front to back are longer and cover the edges of the front and back panel. And the reason being, well, one of the positives is that if you imagine you're going to screw it or nail it from the side, and therefore you're going to be pulling across the screw. I'll just show you a little diagram of what I mean. So the arrangement on the right is how we're going to have it, where the side panel is longer and then you've got your screw coming in from the side, so you're pulling across that screw, whereas on the left you have got the side panel shorter and you've got the screw going end on into the grain, which is one of the weakest points to screw into MDF anyway. The particular problem here is because you're going into MDF really, and as you're constantly tugging on that, you could easily wear it out eventually and pull the screw out. So it's always better screwing from the side when you're doing it on a draw. And the other reason is that you're going to hide the end grain of the front and back pieces. Now, the other question is, do you just use 3 sides to a draw box and then just stick the draw front on? Because now you're losing another 18 mil because you're making 4-sided draw box and then sticking the draw front on. But it is so much easier to assemble, and 90% of drawers out there you'll see will be like that. So I would advise you to build the draw box. Again, if it's your first attempt, just build a draw box and then attach this draw front to it. Okay, so what that means is that we need to bring another guideline over in 0.018, and again another 0.018. So that's going to be the sides of our unit. So let's use these guidelines now and draw the front of our draw box, and then we're going to extrude it 0.018. Now let's make that a component. You make that draw box front or back. Great. Now the depth of the draw unit, the draw box, it could be the full depth, but you don't know how accurate. It's highly unlikely you're going to build it exactly accurate. Even someone like me, I'm going to struggle to build it 100% accurate. So I'm going to allow myself 10 millimeters at the back. So our depth is currently 420, so I'm going to make it 410. And I can extrude that. More than one way to skin a cat. Just going to do it this way myself. Okay, and then we extrude that. 0.41. 0.41. Enter. Right, there we go. That's the draw side. So you see there, it's hiding the end grain of that front panel. And if you had a screw in there and you're pulling the draw that way, you're pulling across the screw in shear strength rather than pulling against the screw. I mean, screws are strong, but eventually, especially in MDF, they can become weak, and you might end up, if you keep tugging on it really hard, you'd end up pulling it off. So that's what my mum said anyway. Hee. Right, let's make this a component. Draw box side. Rotate around. Then we can go to our components. Just a little note about components. If they're not here, just click on this little arrow and go to in model. Sometimes there'll be all the generic components from elsewhere, but I want my draw box side. There we go. And I can place that right there. And then draw box front and back. Done. Okay, so that's our draw box. But what we're going to do about the base. Now this is where it also gets a little bit complicated. You need to decide what use is intended for this drawer, how much weight you're going to be putting in it, and what materials you're going to use. Now I'm using MDF. MDF has got lots of pros and cons, but you know the pros are it's cheap, and I've got some in my garage that I want to use up. So if you're using ply, it's much stronger. You can get away with much thinner stuff, and this really dictates what you do with your base. So with the base, you have a choice. You can mix it up. You can have a plywood base and a MDF box, or the other way around. But in my case, I think I'm going to end up going with a 9mm ply. But you have to decide if you're going to groove it in. Most drawers have a groove inside here. I'm going to show you my existing drawer. So here we have a typical drawer. You can see it's made from a box with a drawer front fixed to it. And I just wanted you to take a look at the base here. This has only got a 4mm ply in it. And you can see when I press it, there's not a lot of give, but it does move. You can see it like that. Yeah, a little bit of movement in there. So you can imagine 6mm is going to be really strong. And that is routed into the sides. Funny enough, it's not routed at the back, but it's routed into the sides and the front. So that's going to be really strong. If it was tacked to the bottom, it would really be a lot less strong, a lot weaker. And they've tacked it in with nails and glue probably. Okay, so that's that. Then we've got our runners, which I bought. And like I say, the distance across there, from there to there, is 12.7mm. But there is actually a little bit of play in this. You can see that. So we allow a mil, that should be fine. So you've got 2mm overall. And the way these work is that slides into there like that. You've probably seen it in the kitchen drawers. You put it in an angle and then the wheel takes it in. They're really simple, but they're very smooth and dead cheap. So because it's coming from the front, this side will go here and you simply fix it to the underside of your drawer like that. And that slides back and forth like that. You can see that. Like that. Simples. It's also valid, you know, a lot of carpenters will tell you, oh, it's not real carpentry. But again, I want something quick, I want something simple. And I have done this before. As long as you put enough screws and glue in it, it's fine. Yes, all right, it isn't as skilled as putting a groove in, but to be honest, I don't want to spend that much time doing it. It's for myself. If it was for a client and they wanted that, absolutely fine, but I don't. But if you want to put the groove in, if it's plywood, if the sides are plywood, this is where it gets complicated. If the sides are plywood, it needs to be at least 6mm from the bottom. Okay, so what I'm saying is the bottom of your groove needs to be at least 6mm from the bottom. If this box is plywood, that's to prevent it breaking out. There's a lot of stress on the underside of that groove. There's only a thin piece of material left over, 6mm. But if it's plywood, it's strong enough, or should be. If it's MDF, it needs 15mm. And that is another reason why I'm going to screw my base to the bottom, because if I put, say, a 9mm piece of ply on there, I'm only losing 9mm in depth. If I do a groove, I'm losing 15mm. All right, so if I was to do it here, I'd be losing 0.015. That's before my groove even starts. And then I've got another, let's say the thickness of the base is 9mm, 0.009. So now I've lost a total of 24mm. Whereas if I put it on the base, I lose a total of 9mm. So that's the argument for and against. If you are going to go for a groove, go for a groove, baby. I would say if it's MDF, it should be at least 6mm up to 12mm and glued all the way around in the groove. If it's plywood, you can go from say 4 up to 9mm, and it'll be pretty strong. Again, it really depends how much weight you're putting in it. If you're putting it to the base, it should be 12mm if it's MDF, if you're going to fix it to the base here, and 9mm if it's ply, if you're just going to screw and glue it. Luckily, there is a tool we can use to calculate roughly what thickness of material we need. And that tool is called the Sagulator. It is brilliant, this thing. I'll post a link. So what I've done is, because I've got some 9mm plywood down the garage, that's what I've put in here, 9mm. Is it fixed to all sides? Well, it's not supported underneath like a supported bridge, but it is screwed and will be screwed and glued. So in my example, it's going to be fixed. The shelf load, I'm going to assume each drawer needs to take 10 kilos. It's quite a lot, but I'm going to assume that. So since my unit is approximately 600 wide, it's 570, but approximately 600 wide, I'm going to say that's 5 kilos per foot, and it's a uniform load, and it's in kilograms, right? So 5 kilos per foot. So it's actually more than I'm probably going to load it with. So the shelf span, actually, go back to my diagram, go back to my model. The span of my sheet, let's measure it on the back here, is only 506 millimeters. So shelf span, let's do it in millimeters, 506. Depth front to back is 410. And the thickness is 9mm. So that should actually be 9. Now we calculate. Borderline. So you get a deflection of 0.67mm over that span. But of course, I'm saying that it's wider than it is, and I'm loading it with 10 kilos, so it's probably actually fine. I shouldn't get hardly any deflection at all. So lots of options there for you guys. Sorry, there's a lot to think about, a lot of different options, a lot of different ways of doing it. Don't listen to anybody who tells you that there's only one way. I think, you know, putting a groove in there, using plywood rather than MDF is clearly going to be a much stronger option. But in this day and age, it's perfectly acceptable with the good glues and fixings we have to do it a simpler way. So, knowing that I'm going to use 9mm, I now obviously need to make all of this 9mm shorter. So exactly the same thing again. Let's move that up 9mm. 0.009. Done. Okay, let's save all that. And we now need to create the base. So let's just draw that on. Extrude it. 0.009. And make that a component. We're going to make that drawer, box, base. Just one final thing to mention about the groove. If you do a groove, if you get into the groove, baby, if you do a groove, make it at least 1 or 2 millimeters wider. You have to do this, right? Make it 1 or 2 millimeters wider than the thickness of your board. So if it's 9mm, make it 10 or 11mm width. It's going to fill up with glue anyway, but it just makes your life so much easier when you go to assemble it. Okay, so that now, I want to make that a group. That's now my box. So I'm going to want to copy and paste that. Wrong bit. One. Let's bring that up. 0.018. And grab it in the corner. And there we have it. I'm not going to put any handles on it or anything like that. It can be sorted out later, but that's basically my model. Let's save that. Here's where the power of open source plugins really comes into play. I've installed this plugin called Open Cut List, and this is going to help me generate a cutting list from this model with very little work. So first thing you're going to do is just select whatever it is you want to make a cutting list for, and then you're going to click on this and maximize it. Okay, so we want to make our materials first. The materials would be things like, you know, the MDF 2x4, whatever you want to use. So let's start with a new material. And this one I'm going to call, because I've got different thicknesses, MDF 18mm. The color, you can choose a color code. So I want it to be brown, so I've just put in a color code for that. And the type, it's a sheet good. You've got all these different options here. There's a great video on YouTube on how to do all this. Length oversize is whether you want it to actually be cut bigger than you want, but I don't want to add any millimeters to the size. So these are your standard sizes. You don't need to do anything here. You just need to check that the size that you want is there. And these are standard sizes, like that's 8x4, that sheet there. Grain follows length. Well, MDF doesn't have grain, so I'm just going to say no grain. And if I wanted a different one, for example, a different size sheet, let's say I've got an offcut I want to use up, I can put in the exact size of the offcut. So let's say 1020 millimeters times, I don't know, 1850. Just as an option, and then we click create. So now we've got an MDF 18mm material. Let's create another one. We call it MDF 12mm. Color, same again. Type, sheet goods. And let's just keep a standard sheet, create. Okay, and then we've got our final material, which would be plywood 9mm. That can be the same color. Sheet goods. It doesn't have a 9mm there, so let's make one. And let's just leave that as standard. And let's just say it follows the grain. Actually, no. The reason that's important, if you say it follows the grain, that means it will orientate it so that it's keeping within the grain, but then that may not be the most efficient use of material, and to be honest, I don't care which way the grain goes inside my draw box. So let's leave that like that. So let's go to parts, generate, and you can see down here it's got all the bits, and what you need to do is go through. So my carcass side is 18mm MDF, so check, click the 18mm MDF. So you've only got to do this once. Carcass base. The carcass base is also 18mm MDF. So I'm just going to go through these. Oops, wrong one. Draw front back box. 18. Right, the carcass back is 12mm. Drawer, box, base, 9mm. Plywood. Apply. That's done. Okay, so for each of these, you can actually see a cutting diagram for the particular material. So the MDF 12mm, let's look at the cutting diagram. It lets you choose the sizes that you put in before, and then generate. And there you go. So that's how much 12mm. So I'm only going to use one piece of 12mm out of a whole sheet. So obviously that'd be better off out of a offcut. And then you can actually create labels, which is incredible. We'll come to that in a minute. So let's go back. There we go, back. Close. There we go. Let's go to the 18mm cutting diagram. Let's go for a standard sheet. No, let's go for our offcut. See if it will fit it all in. So it's actually had to use 2 sheets. So let's change that. Can we change that? Let's change that to an 8x4. Yep, it's managed to get it all in one sheet. So probably I'll be better off just getting a brand new sheet of MDF. And you see how it's fitted it all in there? Now, you probably could allow for the thickness of the blade in between each of these sheets. So you'd want to know what that offcut is there, and I'm pretty sure there's a way of figuring that out, but I don't want to go into too much detail in this now. It's just an amazing plugin. And then the labels thing, this is even better, because of course you're going to have lots of pieces of wood, timber that are going to look very similar. So what you can actually do is have a label for each individual item on here and print it off, and then you can stick it to it. So as you cut them, you know what's what. Just absolutely brilliant. Okay, and then you can print them off, of course. Print off your cutting diagram. You know exactly what you're doing. Just cut it to that size, and that's it. I've actually worked it out, guys. This is actually capable of using offcuts. It's a brilliant, brilliant bit of kit. So if we go into MDF 18, I've put some different sizes in there, you'll see. But then when you come to the parts, so we've got our parts list as I showed you. So we've got MDF 18, let's go down here, go to cutting diagram, and we can choose the different sizes. Now, you could use, you know, a full sheet, and then you can put your offcuts in here. So let's say I have some weird size 1073 times 580mm, and then you have to put the quantity as well, times 1. All right, so it's added that. Generate. So it's actually listed there as the offcut, and it's got the offcut here. So it's using the offcut, and then it's using the full sheet as well. So whatever material you have, you can use this. It's brilliant. You don't waste anything. Fantastic. Right, I hope that was clear for you. Like I say, anyway, I'm going to go down, see what I've got. I'm going to plug those figures into this, print off my own cutting list, and then we can get started with cutting the material. Well, that is it for this video, guys. This is the set of drawers I actually made in the end, and it worked out perfectly. If you want to see that video on how to actually cut and build this thing, then I'll put the link in the description. This video is going to be too long otherwise. Anyway, I hope this was useful to you. If you like the video, please do hit the like button and subscribe to my channel if you haven't done so. I'll be making loads more videos on carpentry, fixing things, sustainability, permaculture, EVs and so on. So we'll see you on the next one. Cheers. Bye.